Hi, my name is Mike Smith, and this is Understanding Floor Division in Modulo, which was created for the Coursera course in Introduction to Interactive Programming in Python. The objectives of the video are to create an understanding of floor division in Modulo using positive and negative integers, to provide definitions of terms involved, show a manual method of calculation for background understanding, show a mathematical formula for easy computing floor division in Modulo, translate this formula into Python code and verify that it matches the internal functions Python provides. First, we'll start with some definitions. Dividend is the number that is being divided. Divisor is the number the dividend is being divided by. Quotient is the result of the division. Remainder is what is left over. Floor division is dividing one number by another and then rounding the result to the closest integer that is smaller. Modulo is an operation done to get the remainder. Over here I have an example. 7 divided by 3. 7 is the dividend and 3 is the divisor. Now if you divide 3 into 7, it goes into 7 two times, which is the quotient, with 1 as the remainder. That means floor division, 4 divided by 3 equals 2, which is the same as the quotient, and modulo 7 mod 3 is equal to 1, the remainder. We're going to do some manual floor division in Modulo using plus and minus 9 as the dividend and plus and minus 4 as the divisor. Down here you'll see a table that shows dividend and divisor. Now if the dividend is positive, then both the quotient and the remainder will be the same. If the divisor is positive, then they're both positive. If the divisor is negative, they're both negative. If the dividend is negative, then the quotient and remainder are opposite. If the divisor is positive, so is the remainder. Therefore, the quotient is negative. If the divisor is negative, so is the remainder. Therefore, the quotient is positive. Okay, we'll start with our first example, which is 4 divided by 4, which is this case here, where both are positive. So what we want to do is we want to get to a remainder that is close to 0. So in this case, we'll take 9 minus 4, which equals 5. So far, our quotient is 1. Now we'll take 5 and subtract 4 from it, which equals 1. So our quotient is 2. Now since we're between 0 and 4 here, with a remainder of 1, that is our answer. So 9 mod 4 equals 1. Now to check this, we can multiply the quotient, which is 2, by the divisor, which is 4, and then add 1, the remainder, to get 9, which is what we started with. Okay, here we are in the second case, which is 9 floor divided by negative 4. So we are in this case here. So we start off doing 9 minus 4 equals 5, which gives us 1 for the quotient so far. Then we can do 5 minus 4 equals 1, so we do 2. And since we need the negative, we do it once more. 1 minus 4 equals negative 3. So our quotient is negative 3, and our remainder is negative 3. Therefore 9 mod negative 4 equals negative 3. Checking our work, we do negative 3 times negative 4 plus negative 3 equals 9. And 9 is the same thing as we started with up here. Third case, we have negative 9 floor divided by negative 4. They're both negative, so we are in this case here. So since we need to work towards 0, in this case we have to add 4. So negative 9 plus 4 equals negative 5. So our quotient is 1 so far. Negative 5 plus 4 equals negative 1. So our quotient is 2, with a remainder of negative 1. So negative 9 mod negative 4 equals negative 1. Checking our work, 2 times negative 4 plus negative 1 equals negative 9. Therefore, since it's the same up here, that is correct. And for the fourth case, we have negative 9 divided by 4. So the dividend is negative and the divisor is positive. So now we're in this fourth case. So here again we're trying to get towards 0, so we have to add 4. So we add 4 and we get negative 5. So quotient is negative 1 so far. Then negative 5 plus 4 is negative 1, so now it's negative 2. We look down here, we need our remainder be positive, so we have to keep going. Negative 1 plus 4 equals 3. So we did that 3 times, so the quotient is negative 3, and remainder is 3. So negative 9 mod 4 equals 3. And again, checking our work, negative 3 times 4 plus 3 is equal to negative 9, which is indeed what we started with. Now, on to using the formula calculation. 15 floor divided by 4 is the floor of 3.75, because 15 divided by 4 is 3.75. Doing a floor calculation basically means finding the integer that is smaller than this float, which is 3. So 15 mod 4 is the dividend minus the quotient times the divisor. So in this case, that's 15 minus 3 times 4, which equals 15 minus 12, and therefore it equals 3. Now to check our work, the dividend should equal the divisor times the quotient plus the remainder. So that's 4 times 3 plus 3, which equals 12 plus 3, and then works out to 15. And we can see that that is what we started with, was 15. The second case, using the calculation, 15 floor divided by negative 4. In this case, it's negative 3.75 for the floor. Since we need to go to the next smallest integer, that would be negative 4. So 15 mod 4, using the same calculation, is the dividend minus the quotient times the divisor again. So 15 minus negative 4 times negative 4 equals 15 minus 16, which equals negative 1. Now checking our work, the dividend equals the divisor times the quotient plus remainder, as it is in every case. So negative 4 times negative 4 plus negative 1 equals 16 plus negative 1, or 15, which is what we started with. Case number 3, negative 15 floor divided by negative 4. So again, we take the floor of 3.75, which is 3. So negative 15 mod negative 4 is the dividend minus quotient times divisor again. So we have minus 15 minus 3 times negative 4, which is equal to minus 15 minus negative 12, or negative 3. Now checking our work, using the same formula, we have negative 4 times 3 plus negative 3, which is equal to negative 12 plus negative 3, or negative 15, which is indeed what we started with. Now for the last case, negative 15 floor divided by 4 equals the floor of negative 3.75. Again, we get negative 4. So negative 15 mod 4 from the same calculation gives us negative 15 minus negative 4 times 4 equals negative 15 minus negative 16, which results in 1. Now checking our work with the same formula, 4 times negative 4 plus 1 equals negative 16 plus 1, which equals negative 15, which is indeed what we started with. Now we'll take a look at code for this in Code Sculptor. We start off with from math import floor to give us the floor operation. So now we have a function here called define floor div, which takes in a dividend and a divisor and calculates the quotient. The quotient, the same as we did previously, is the dividend divided by divisor, and then we take the floor of that and return it. The modulo, the same as we did previously, takes the dividend and the divisor, gets the quotient by calling the floor div function, and then gets remainder from the formula we shown previously, dividend minus quotient times divisor, and then returns the remainder. So then we have the mydiv function, which takes the dividend and the divisor. It gets the quotient from the floor div function. It gets the remainder from the modulo function. and then it prints the result. Then we also get the quotient by using the built-in Python function and remainder using the built-in Python modulus function, and prints that result. And down here we print results, and then we print an empty line, and then we call mydivMod with our first case 15 and 4. So we'll run this and see what we get. We get results. Floridiv and modulo are 3 and 3. Using the built-in functions, you can see it's the same, 3 and 3. So let's uncomment the next line of code and see what our second case shows, 15 and negative 4. Again, both the function we created and the internal function give the same results. Okay, on to the third case. The third case, as you can see, gives us the same results. And finally, the fourth case gives us the same results as well. And these are all the same results that we calculated. Thank you for watching this video, and hopefully it helps you understand floor division and modulo.